Hi guys, we continue with the electrostatic force Coulomb's law example. We start with example number 1. Let's assume there are two charges again. One positive charges Q1 equal to 2 microcoulomb, and then at a distance away there is a negative charge of Q2 equal to negative 5 microcoulomb, where the distance between them is, let's say, 0.45 meter, which is 45 centimeter. Okay. Now the question is, calculate the force on Q1 and Q2, both of them. Okay, for both of them. So this is how we solve it. First, there are steps in solving a physics question normally. Number 1, we label or we draw a diagram. If diagram not given, you normally translate the meaning of the question into a diagram, so it's easier for you to understand. So in that case, diagram is already given, so we label whatever you are asked to calculate. For example, in this case, you are given two charges, Q1, Q2, at a distance 0.45 meter, and then you are asked to find the force, okay, experienced by Q1 and also Q2. So we label the force. But first, before you label the force, you need to know what are the interaction between them. Q1, Q2, one positive, one negative, they will be attracting each other. So we have forces in between them. This one and this one. So this force, I label it as 1, 2. And this one will be 2, 1. Okay? Force 1, 2, 2, 1. We already talked about the labeling of subscript from the previous videos. So F12 and F21, if you look at it carefully, these two forces are opposite in direction, but they are the same magnitude. Alright? So that means if you are asked to calculate the force on Q1, Q2, it means that we only need to calculate one. The other one has the same magnitude, so we don't repeat the same procedure again, right? So now force F12 is K Q1 Q2 over R squared. So magnitude only. Now since the question didn't mention what medium the charge will be in, so we assume that it is in vacuum. So our K will be 8.99 10 to the power 9. So our K value, that is K equal to 8.99 10 to the power 9, and then the charge will be 2 microcoulomb and then negative 5 microcoulomb. Divide by distance 0.45 square. Right? This one I need calculator to calculate the value. 2 times 5 times 1 10 to the power negative 12 times 8.99 power 9 divided by 0.45 square. Okay, so the answer is 0.444. 0.444 Newton for F12. But F21 is also the same magnitude. So the magnitude of F21 is equal to the magnitude of F12, so which is also equal to 0.444 Newton. Alright? But force is a vector quantity. Other than magnitude, you also need to give the direction. So in that case, we look at F12. F12 pointing to your right hand side. Right hand side is your positive x, and then your left hand side is your negative x. But in physics, we normally use, we don't use direction x or direction y. That is quite a low level language we use. But we use the simplicity of mathematics. Okay, we use I, J, and K. So your positive x direction is referred to positive I, and then the negative x is negative I. Okay, and then going up, which is positive y, that we refer to positive j. and the opposite will be negative J. At the moment, we don't talk about the third axis yet, but in magnetic field later in the subsequent chapter, we're going to talk about the Z axis. That one is next chapter, next chapter. So F12 pointing to your positive X. So the direction of F12 is 0.444. You multiply by positive I. So you end up like this. Positive 0.444 I Newton. So this answer tells us two things. The magnitude of the force, which is 0.444, positive I point to the positive X direction. Simple, right? And then the next one will be opposite. This one is 0.444 but negative I. So you get negative 0.444 I Newton. Alright? So that is how we give answer in electrostatic force, especially the one that deal with a lot of forces together. Okay, so this is one of the easy example to calculate electrostatic force in between. All right. The next example. Okay, our next example would be slightly more difficult than this one. I normally give example according to difficulty. Now, example number 2. Now we have 3 charges. Okay, we have 3 charges. This is y-axis. This is our x-axis. So I have one charge here. I call this one Q1, which is 3 microcoulomb, and then this one is Q3. Q3 is negative 6 microcoulomb. And then we have another one here at the intersection here. This is the third charge. Okay, this is Q2, not third, second. Q2 is equal to negative 7 microcoulomb. Right? So the information given to you will be the distance between them. So this one is, let's say, 30 centimeter. This one is 40 centimeter. That means from the origin to the charge 40 and 30 respectively. Question is, calculate the net force on Q2. Right? You calculate the net force on Q2. Alright? So, question already given. Do like what you did before in example 1. So example 1 show that our step number 1 is to label all the forces involved. So in this case, question say on Q2. That means you only label the forces on Q2. Q1, Q3, there's no need. Okay, we couldn't be bothered because we only asked for Q2. So we look at them pair by pair. You look at the interaction between Q2 and the rest of the charge. We start with Q1. So if you look at Q2 negative, this one positive, so that means Q2 will be attracted to Q1. Okay. So this one is F21, right? The force on charge number 2 because of charge number 1. And as we know, there is another force here, like that. F21 and this is F12. But we are not asked to find out anything on Q1, so we drop out that vector. Okay, so that is not making our diagram even more complicated. Next one is Q2 and Q3. Negative, negative, repel. Okay, so that means Q2 will be repelled away, and this is labeled as F23. Okay, F23. But we also know that other than this, there is another force here, which is F32. But we are also not asked about Q3. So we don't draw that force. So that means we have only 2 vectors for the force in our diagram here, which instead we have 6 altogether. 1, 2, 3, 4, 5, 6. Okay. So to make our calculation simpler, we only draw 2 so that our diagram does not look that complicated. Because that 2, another 2 forces on Q1 and Q3 actually does not help us. Okay. So now next one is, so our step 1 done. Step 1. Label. Our step 2 now, you find the magnitude of the force. Since you already labeled two forces, that means there will be two magnitudes for the forces that you already labeled. So our first one is F21. Okay, F21. Okay, Q2 Q1 over R squared. Now there is a little bit of changes here. This F21 is using this distance, and that distance is 40. So we use a subscript which is the same as this force. Okay, a force F21 refers to the distance between Q1, Q2 and Q1 and the distance of R to 1. Well, it might look very complicated at first, but try to get used to it, because this one is to help us so that we don't get confused with the distance. We don't use the wrong distance during our calculation. Okay, so here we put in a value. Same thing, K, I don't put in a value anymore. K, you already know K is that value, so I'm lazy to write the K value. So now our Q2 is -7 microcoulomb, and our Q1 is 3 microcoulomb, and divide by a distance of 40. 40 square, but be careful, 40 is a centimeter, so it changes to meter, becomes 0.4. Okay, let's find out what is the value for the force here. So we have 7 minus 6 multiplied by 3 power minus 6 multiplied by 9 power 9 divided by 0.4 squared. So my answer here is 1.18. Okay, 1.18 Newton. Okay, 1.18 Newton. Then come to the next one. Our force F23. That is K Q2 Q3 over R23 squared. Okay, okay. This is 7 microcoulomb negative, and then here is -6 microcoulomb, and then divide by distance. Now this distance is 30 cm, so 0.30 squared. Let's find out what's the value for this force. Okay, so we get 4.2. 4.20 Newton. Okay, 4.20 Newton. Well, that's a magnitude for the force F21 and F23. But question asking for net force. So net force means you have to sum up all the forces for F21 and F23. Alright? So we find the net force. Our net force here, before that, we need to change the force into a vector form like this one first. Okay? So our F21 is pointing to your negative x direction, so our force will be 1.18 positive I Newton. Remember that? Okay? Just now from the experiment, from the example. And then our F23 pointing upwards, so we have a positive 4.20 J Newton. That's the answer for the vertical force. Okay? Positive J because pointing up. Now our net force is you combine everything that you calculated in this number 2. Sorry, this step here we call step number 3. When you change the vector, we call it vectorization. Okay, vectorization. Same like this step. This is the vectorization where you change it into a vector format. This one is the same. So in step 1, you label. Step 2, you calculate the magnitude. Step 3, you change them into vector format I and J. Okay? And then step number 4, we sum up. Okay? Sum up means you find the net force. So how do we sum up? Because they are vector, you can simply sum up F21 plus F23. Okay? F21 plus F23. So we have this one already, so we just simply put in 1.18 I plus 4.20 J. Everything in Newton. So that is our net force for example number 2. You can see that the difficulty increase. Okay? Here we only have step 1, 2, and 3. Here we add in one more. The most difficult type of question for this type is that will be step 5. Okay? That one will look at in a subsequent example. Alright? Okay. So far for these two, wait for the next video. Thank you.